In this video, we're going to look at the greatest common divisor, or GCD. And if you're wondering why we would want to study something like this, imagine we have two numbers, A and B. We want to find another number, x, such that when we divide A and we divide B, there is no remainder from either of these results. Now in general, there are two methods for solving these types of problems. The first method is when you are looking at the numbers and they're easily factorable. The second method is when you look at your numbers and it's not so obvious. Now the reason I'm making this video is to really demonstrate the second method, but for the sake of completeness, I'll go ahead and quickly review the first method. The way that I'll demonstrate this is I'll go through an example, and as I work through the example, I'll explain the steps that you can take to follow the process to come to the answer of the GCD. So with the simple method, the first step is to take your numbers and write them in a line. These are the numbers that you're looking for the greatest common divisor for. We'll use an example of 28, 140, and 420. So after you've written your numbers in a straight line, we're going to use short division, and we're going to divide each number by any common divisor, writing each quotient below its dividend. So at first glance, we can see that 7 is a factor of all these numbers. So we'll go ahead and divide, and we see that this is 4, this would be 20, and this would be 60. And we would continue this process until the numbers are no longer factorable. So from here we can see 4, and this would be 1, 5, and 15. And from here we can see that there are no more common factors that we can work with other than 1. So from here you would take all of your divisors and you would find their product. So 7 times 4 is equal to 28. And this number would be our GCD. Now the second method is when you have some numbers and it's not so obvious from just a glance. So similar to the last example, I'm going to walk through an example problem, and as I work through it, I'll explain the steps that you can follow. After we do this, we'll do a simple small example, a word problem, and then we'll end the video with the steps written out such that you can write them down and apply them to future problems. So first, let's get some numbers that we can find the GCD for, where it's not so obvious. For this example, we will use 18,607 and 417,979. Now, just looking at these numbers, at least for me, it's not so obvious what their factors are. The process begins as follows. We always start with two lines. With your two numbers, what you want to do is you want to take the larger one and place it in the top right corner. So 417, 979, and then you take the smaller number and you put it off here to the left. Now from this step, we are going to perform division with the smaller number into this larger number. Division as you normally would. So we'll look, how many times does 18,607 go into 41797? And the answer to that is 2. And this result is 37,214. And we'll subtract. And this gives us 4,583. And then we just bring the 9 down as we normally would. So then we want to continue with the smallest number into the larger number. So looking at this, we can see that 18,000 is smaller than 45,000. So how many times does this number go into the larger number? Well, again, it's going to be 2 times with the same number, 37,214. This would give us 8,625. Okay, now something interesting. This number is now smaller than this left number. So what we'll do is we'll start from here and we'll ask how many times does this number go into the larger number. Similar, just swap sides. And the answer to that is about 2 times. and that comes to be 17,250. We'll subtract, and that gives us, and we'll bring it down to kind of keep things in line, 1,357. Okay, so we swap back to this side. Now this is our smaller number. So what do we do from here? Well, how many times does this go into the other number? And that's about 6 times. And that equals 8,142. We'll subtract again, and that gives us 483. Again, swapping sides. How many times does this number go into the other? That would be 2 times, for a total of 966. Subtracting, and that gives us 391. How many times does this go into the other? And I hope you're starting to see the pattern from here. So this goes into it 1 time, minus 391. That would give us 92. How many times does 92 go into 391? About 4 times, for 368. We'll subtract, and this gives us 23. Now, how many times does 23 go into 92? About 4 times, and that gives us 92. And now we notice something interesting. We get to 0. So once you reach this point and you have the value 0, the last number you were using is your GCD. So 23 in our case is our GCD. Now you also may be wondering, well, what if we had other numbers? So for example, we had some third number x. Well, what you would want to do in this situation is you would take this GCD, 23, and you would apply it to that other number x. And you would start by putting the larger number here, whether that's the GCD or x, and putting the smaller number here. So now that we've seen the process, let's go ahead and apply it to a word problem. So for this word problem, imagine we have 2 friends, Sarah and Jake. Sarah and Jake are planning a party where they want to hand out gift bags to their friends. And in these gift bags, they're going to put chocolate and candies. Sarah, she has 24 chocolates. Jake, he has 36 candies. So our question is, what is the greatest amount or number of bags that they could create to hand out to their friends, given these numbers? And the keyword that we should pick up on is greatest. What is the greatest way that we can divide these numbers such that each bag has the same amount of chocolates and the same amount of candies? Now, looking at this problem, it's pretty obvious that we could use the first method to solve this problem, as these numbers aren't too large. I find myself in practice using the second method more often, so I'll go ahead and demonstrate with that method, similar to how I described it previously. So again, we start with the 2 lines, and we'll write our larger number at the top and our smaller number off to the left. If you would like, you can go ahead and pause and try this problem on your own and see if we come to the same conclusion. So, how many times does 24 go into 36? Well, it's just the 1 time. So this would be 24. Subtracting, we get 12. How many times does 12 go into 24? Remember, we're going to continue this until we get to 0. So how many times does 12 go into 24? Well, that would be twice, which is 24, which is 0. So again, the last number we were using, 12, this is our GCD. So what does this mean? Now, before I just say it, ask yourself, what does this number represent for our problem? And the answer is, it means that we can divide the candies up into 12 bags. Now, another question for you might be, how many chocolates and how many candies would be in each of the 12 bags? Talking it out loud, if we have 24 chocolates and we have to divide it into 12 bags, that means that we would have 2 chocolates per bag. And how many candies? Well, if we have to divide 36 candies among 12 bags, that means that we have a total of 3 candies per bag. Now, this was a very trivial example, but I just hope it goes to show that this method is very simple and an easy algorithm that you can follow to find the GCD of some given numbers. Now, as promised, I'll go ahead and insert the algorithm that you can follow to find the GCD of future problems that you may encounter. And here are the steps that you can follow. If you would like to pause the video and take a picture, feel free to do so. Now that'll be all for this video. If you have any questions or comments, please feel free to leave them down below. If you found this video helpful, please consider liking and subscribing. And until next time, thank you.